SCIENTIA-2k22. Now, we shall invoke the Almighty to bless us on this fortunate day, calling over Tanisha N to do the same. Thank you, Tanisha. I request our respected principal to welcome the gathering.
Respected dignitaries of the dais and all the dais. It's my pleasure to welcome a great personality of the day, and you will know what highest level sir has reached. Sir, it is our privilege for this particular program. Dr. C.V.Yelamaggad, Fellow Royal Society of Chemistry. It's our lucky day, we can say. Sir, I welcome you for this particular program. And well-known person, Dr. Chennai, I think Inspire Program Coordinator. I welcome I've been called captain, an honorary rank, but always captain is our CEO. I welcome our CEO, sir, to this particular and I welcome our vice principal to this particular function. And all faculty members and non-faculty, non-teaching staffs for this particular function, I welcome you all. And dear students, you are the most important for the day. You are the youth icon and future India, future scientist, and I don't know where you are all going to place. And it's our institution is providing the opportunity to focus on various areas. And we have a great personality, the topmost scientist in the world, can say. So, I also welcome you for this particular function. Thank you.
Also welcome our beloved principal, Mr. Mahabaleshwar Tunga sir on this occasion. Next, we have lighting the lamp ceremony. please the goddess of wisdom for her blessings by igniting this lamp. I request all the dignitaries to light the lamp. To to introduce today's chief guest.
Good morning everyone. I am from Bengaluru and I am here to introduce the chief guest of the day, Dr. C.V.Yelamaggad. Dr. C.V.Yelamaggad has obtained his MSc and PhD degree in organic chemistry from Karnataka University, Dharwad. Sir carried out his postdoctoral research for 3 years at the Department of Organic Chemistry, Indian Institute of Science, Bengaluru. Later, for a couple of years, he was the senior scientist in the R&D division of the private chemical industry. Then he moved over to the Department of Organic Applied Chemistry, National Southern University, Taiwan, to carry out postdoctoral research. Ever since 1997, Sir has been a scientist at the Center for Nano and Soft Matter Sciences, Bengaluru. His work focuses on soft matter, nanomaterials, nanosoft composites, and other closely related functional materials that are promising from the viewpoints of both functional research and advanced technology. Dr. Yelmaggad has made many noteworthy scientific contributions in the field of liquid crystals with his journal research publications numbering over 220. Besides, Sir has 10 national and international patents to his credit. Sir has guided over 9 PhD students and 5 postdoctoral researchers and several project assistants. Dr. Yelmaggad has been the principal investigator for research projects sponsored by governmental agencies. His research accomplishments have been well recognized at the national and international levels. Sir has presented over 320 invited lectures and written reviews in journals and textbooks. Dr. Yelmaggad has been the recipient of state government's national and international awards, namely Japanese government's GST Fellowship for the year 2000, Japanese government's JSPH Fellowship for the years 2002 and 2003, Government of Karnataka's Sir C.V.Yelamaggad Young Scientist Award for the year 2005, the Royal Society's London Visiting Fellowship for the year 2007, MRSI Materials Research Society of India Medal 2019, Indian Institute of Science, Bangalore, FRSC Fellow of the Royal Society of Chemistry Award from the Royal Society of Chemistry, London, UK for the year 2019, Silver Medal, Chirantan Rasayan Sanstha, Vidyasagar University, West Bengal 2020, CRSI Chemical Research Society of India Medal, Indian Institute of Science, Bangalore 2021. Dr. Yelmaggad has been listed in the world ranking of top 2% scientists from India. Sir is one among the top 1.2% scientists list of India. Dr. Yelmaggad has been elected as an executive member of RSC, Deccan Section and Secretary, CRS Vidyasagar University, West Bengal. Dr. Yelmaggad has also been active in educating college students and teachers about liquid crystal science and technology through his inspiring talks at refresher courses and sciences popularization programs. It is an honor to invite such a great personality to inaugurate our science club. Once again, we welcome you, sir.
Now, felicitations of the chief.
has a lot of significance, I can understand. It has the art significance.
Great to have a few words from our eminent chief guest. The stage is all yours, sir.
Yeah, thank you. Good morning, sir. I can't hear you. Had your breakfast? Yes, sir. Good morning, everybody. Good morning, sir. At the outset, I would like to express my deepest gratitude to Sri Soundaryati Jippa and his wife and children, Ketan Kumar and Varun Kumar, and the principal of his college for having me invited here to present a talk. Today I am going to talk to you on one of the important aspects of science, without which none of you, meaning any living thing that exists on the earth that could not have survived without the presence of these states of matter. I shall repeat. Okay? We all living systems on this earth, I think to the best of my knowledge, living beings are only on this planet. Am I right or wrong? Yes, sir. Am I right or wrong? You have to be louder. Yes, sir. Okay, first thing, there will be some kind of agreement between you and me. You have to keep answering. Not that you have a heavy breakfast and come and sleep here. No, I won't allow. I am very careful observer. I can see each and every eye. Your eyes are with me. Okay? If you are getting bored, please tell me. I'll have some jokes, science jokes. Okay? Yes, sir. You have to be with me for 2 hours. Is it okay? Yes, sir. Is it okay? Yes, sir. Yes or no? Yes, sir. Okay, then give a big round of applause to your principals. And a very big round of applause to management, our CEO. Okay, can you sit straight, please? Little bit straight. Okay, very good. Can you give one more round of applause to me? Thank you. No, scientists, you must understand that scientists are clever. Do you agree or disagree? Yes, scientists are clever. Do you agree or disagree? Yes, sir. Those who are clever here, they are going to be scientists. Do you agree or disagree? Yes, sir. No. Do you know why did I ask you to clap? Do you know why? Yes. Those who are sleeping, they will wake up. And better. This one. What is it called? Blood circulation. Okay, then you will be alert to listen to me. Okay. In the first place, I would like to say that today I am going to talk to you about a fascinating aspect of science, and it has led to many technological implications. It has a lot of technological implications. Right now, you have it. Okay, all of you, whether you have a pen or pencil or notebook, even including me, whether I have my wife besides me or children besides me or not, but definitely I will not forget to take my mobile. Do you agree or disagree? Yes or no? Yes, sir. Why you are so dull here? You agree with me? Yes, sir. This mobile is called cell phone. So this cell phone has an active mirror or active one small piece of a image. Means it has a panel called liquid crystal panel. All of you know. Apart from that, you have a wristwatch. Am I right? Yes, sir. Apart from that, you have televisions now and laptop computers. All that. It has made our life easy. Imagine you using something else, some other active media for this technology. It would have been impossible. Our life has been very easy because there is something called liquid crystal state. Okay? That's one part. Another part is, as I mentioned in the beginning, I or you would not have existed. Forget about I or you. Right from unicellular system to, we are multicellular systems, isn't it? Right from journey from unicellular system to multicellular system, we are composed of what are known as liquid crystals. Means you are a bundle of liquid crystals. Okay? Well, today I am going to talk about that. Without that, none of us would have existed on this earth. That is present in your body in terms of 10 to the power of 14 numbers. What are they? Do you know that you are composed of liquid crystals? You never knew this. Yes or no?
Yes.
Today only you came to know that you are composed of, or you are a bundle of n number of liquid crystals in one or the other forms. Then is it not interesting to know about it? Any kind of disease or any kind how your health is, whether although you are young but you look old, the person who look old, those who are old, they look young like me. Yes or no?
Yes, sir.
You know my age?
No, sir.
I am 58 plus. Right? It is just simply because I know how to take care of liquid crystals present in your body. Okay? I can run 22 kilometers with you right away. The only thing is that I know how to take care of my liquid crystals present in my body. How? You can look, you can be very healthy. You will be away from blood pressure or whatever, all the diseases. Even there are some diseases which are, I don't want to name. Okay? You can address all these provided you know how to take care of yourself. First and foremost, if you know how to drink water, those who have the habit of drinking water about 3 to 4 liters per day, they are the healthiest person. Okay? You know, Tumkur Swamiji, let me present. Okay, by the way, I am quite spiritual. You cannot distinguish between science and spirituality. Okay? They are one and the same. They are two faces of a coin. Okay? You cannot separate. So, those who have the habit of drinking water, you catch me? Those who have the habit of drinking water, is it not common? Whenever you talk to your doctors or elderly people or teachers, they ask you to keep drinking water sip by sip, not gulping. Okay? Every day, sip by sip, about 3 to 4 liters of water you have to drink. The reason is very simple. I am a big fan of it, and I can tell you, I can be as healthy as you now. Because you come with me now. I can run, I can walk with you, I can do anything you do. Okay? The reason being, I know how to take care of myself just by drinking water with you. Trust me. Okay? With water, just with water, you can be very, very healthy. But there is this way of drinking water. Not that I gulp 3 liters of water and go away. No. It is you have to drink water in a very, very systematic way. Okay. Is it not inspiring to you that in what way it is connected? Liquid crystals, water, very well connected. Okay? You have n number of liquid crystals in your body. My best statement is, very attractive statement is, you are a bundle of liquid crystals in different forms. Okay? Now, if you keep supplying water, if you keep drinking water, then you will be very healthy. You don't have any diseases. I can challenge you. Okay? From today onwards, you have the habit of drinking water, especially early in the morning. Okay? At least 1 liter of water with a half spoon of jaggery or lemon. Sorry, lemon is a must. Either jaggery or honey. Okay? Drink. Just warm, drink, even before brushing your teeth. Let me see what will happen. Even it is a medicine for those who are under depression. Okay? Early in the morning, those who have the habit of drinking water, they survive long. The best example is our Shivakumar Swami. Okay? Give big applause to him. These are I am a scientist. I should be telling you the proper things. Okay? I am a scientist. I have my own way of thinking. I have demonstrated over the years, 30 years, through my research or my demonstrations or my suggestions. Those who had a serious problem in their health, they have overcome. I get almost everyday emails. Sir, you presented a talk there and we have improved our health. Just see the difference, okay? And your mother and father, especially your mother, do you know the contribution of your mother? You come here on right time and you go, you go, pass through many periods, the classes, and then go home. Again, your breakfast is ready, or lunch is ready, or dinner is ready, whatever it is. Mothers, they strive hard. They forget to drink water. Yes or no?
Yes, sir.
Morning 5:30. Yes or no?
Yes, sir.
Morning 5:30 or 4 o'clock, including you mothers, teacher mothers also. Okay, they get up at 4:30 or 5 o'clock. We don't know. And they keep feeding you, they keep serving this family, yes, without bothering about themselves. Ask your father or mother, keep drinking water once in a while. Call once in a while. You fill 2-3 liters of water, Amma, you drink. By the time I come back, I should see that it should be empty. Okay? The simple thing, can you not do this?
Yes,
They remain very healthy. There is nothing beyond health. Will you agree or disagree?
Yes, sir.
Agree or disagree?
Yes, sir.
Today, I am going to talk to you about liquid crystals. In what way they are helpful as far as your life is concerned or the technology is concerned. So, okay, you understood what I said? Right. Okay, I think you are very blessed because Professor Bharat Ratna, Professor Sena Rao, who is my mentor. By the way, please give a big round of applause to him. I think you are the luckiest person. As far as I am concerned, you are the luckiest person because there are divine blessings by him, and therefore this school is running. Okay, so he is a person. I think he is no less than a god, as far as I am concerned, because the kind of research he has done, not 1% I can do. Okay, the number of publications, the number of students he has produced, the number of quality research articles he has produced. There is no match, okay? But somehow I feel that he should get Nobel Prize. He should get, because he is working on different areas and they are very, very important as far as we human beings are concerned. Okay? With that, okay, let me say a few words about from where I am coming. I am working at Center for Nano and Software Sciences, which is about 15 kilometers away from here. It's a 14 acres of land. It's a new building has come up. And before that, we were in Jarhadi, very close by Jarhadi. You know Jarhadi? So now we are shifted from here to there. Now, I have shown 3 gentlemen. You can easily identify who he is this.
Battery today, battery.
Can you pick up the slide, please?
Battery.
Pick up the slide. Sir C.V.Raman, who won the Nobel Prize, okay, because of the Raman effect. Are you aware or no? Yes. Now, here is gentleman, he is called Professor S. Chandrasekhar, who is my mentor, who appointed me to work there. I was supposed to follow with him. So, when I was in Taiwan, he invited me to work with him. Professor Chandrasekhar, Shivarama Chandrasekharan, and there is one more Subrahmanya Chandrasekharan. These are relatives, okay? Professor Chandrasekhar is a nephew of Sir C.V.Raman, means Tangi Dodda Maga, okay? He is the elder brother's son. So he won the Nobel Prize. He got the Nobel Prize. I am very happy to let you know that he was nominated on 3 occasions for Nobel Prize. Bring a round of applause to him. Okay? So I really miss you, sir. And whatever I am today is all because of this gentleman. Give a big round of applause to him. So, can you look at them? They have identical features. Look at the nose. Yes or no? Yes. Let us do this experiment. How does it look? C.V.Raman, right? Now, this guy? Yes. All of them, especially nose. I am fond of their nose. Beautiful nose. Okay? So, I am really blessed to be associated with such great person. I worked with him for more than 20 years, and whatever I am, whatever science I have learned is because of these brilliant people. Okay? It means that I worked with the Nobel laureate. He was not less than a Nobel laureate. Okay? The way they talk, the way they present things, the way they think about science is entirely different. If you go to him, just talk for an hour, he would tell you a research of 30 years. In half an hour, they would cover what kind of research you should undertake for 30 years. Okay? He has given me some problem, till today I have not able to solve. So that is kind of thinking. Their brains are different. Professor Sena's brain is totally different. you cannot match. You cannot match their brain holding. They have a lot of holding, it seems. I don't know. But the way they talk, the way they think, the way they project themselves is totally different. Well, with this note, let me start my presentation. Yeah, this is our laboratory. Recently we took, where am I? Here?
Yes.
Right. So this is a small family. It's a very small family. We are about 180 people. Okay. So I am taking care of organic divisions. Okay. He is our director. This is Professor Kulkarni. He is a Prasad, and Amna Prasad. This is our director. He sooner or later is going to visit you on 25th. I something scheduled, right? 25th is going to visit your college again. All that is coming here. Okay. Well, with that, you are ready to listen to me now about subject?
Yes, sir.
As I mentioned to you, today I am going to talk to you about one of the fascinating aspects of science, a topic called liquid crystals, which form the basis of any living being which are present on this earth, without which none of the living systems would have existed on this earth. That is statement. Everything started with liquid crystals, and now we are here. Everything started with one cell. It became 2, it became 3, it became 4, it became 5. Now we are a multicellular system. Now, therefore, ladies and gentlemen, it's important to know what are liquid crystals technically. Okay, let's try to understand technology, then we'll come back to biology. Okay, is it interesting or boring?
Yes.
How many of you are interested? Raise your hand. Oh, to all of you. Okay, very nice. Okay, fine. Somebody didn't raise their hand, don't worry. Okay, fine. Right from your school days, listen to me carefully. Is it boring?
No.
You should not take any notes. Please close your notebook. I hate anybody taking notes. Close. You should. I'm a sharp man today. Okay. Yes, sir. Right. Right from your school days, you have been made aware of the existence of different states of matter. Yes, I.
Yes, sir.
Okay. You know solids, liquids, gas, and plasma. In every day, in your day-to-day life, you come across with these different states of matter. Even teachers have taught to you whatever objects you see, you know how to categorize them, right? Solid, liquid, gas, and plasma. Okay. So before that, let me tell you some important aspects of science. Why? Whatever these research, they have a number of research organizations in Bengaluru itself. Okay. Raman Institute, Pune Prajna Institute, and JNCR, ISC, SENSE, where so many people. What are we doing? So there are some global challenges for scientists. There are some challenges. First and foremost, already you have experience. You sat at home for 2 years. What is that? Because of COVID. Okay, we didn't have any medicine for COVID. So that is one of the challenges we have. Of course, we have worked out, but sooner or later, again, it's going to evolve in different form. As scientists, I may say that it will come in a different form, but again, we have to struggle like this because that was one of the deadliest virus we ever found, science ever found. Because the mutation is very fast. Okay, you must have heard Omicron, all that. Okay, doesn't matter. Don't worry. Now you are immune because of the vaccination. Okay. Now, what is a big problem in the days to come? You will get your drinking water in petrol pumps, 1 liter, 2 liter, 3 liter. In the days to come, trust me, in Bengaluru, in the days to come, the span of about 10 years down the line, you have to be in the queue to get your drinking water. I'm sure about it. Some of are blessed, okay, because we are polluting water. Okay, that's the first, how the oil prices have gone up. So it's a more challenge to the scientists and shelter, health, safety, energy, pollution, and so on. So we as scientists have a lot of challenges. Okay, huge number of challenges. It's very difficult to work. So I'm trying to work on a different aspect of this. Now I'm trying to work on energy and pollution, and there are some other aspects like lyotropic liquid crystals and thermotropic liquid crystals. We are trying to work on that for different reasons. If I understand the behavior of what are known as lyotropic liquid crystal, then I should be able to solve each and every problem that are associated with our health. Any big disease that we have that can be addressed systematically, very systematically, without any medicine, using the principles of what are known as lyotropic liquid crystals. Okay, I shall come back to that point a little later. But as I said, now one technical word I am using. You are composed of n number of lyotropic liquid crystals. What are they? Lyotropic liquid crystals. Whereas in your mobile, or you have panel, right? Or laptop computer or television, you have liquid crystals that are called thermotropic liquid crystals. In your body, you have lyotropic liquid crystals, but in technology, we have liquid crystals that are called thermotropic. Therefore, liquid crystals are categorized into two. One is thermotropic, another is lyotropic. Hey, somebody is sleeping here. Are you sleeping? No, sir. Okay, you give me a big round of applause to me. Okay, come back quickly. Okay, as I was telling you, today I am here to talk to you about liquid crystals. Okay, you know right from the beginning, you are aware of the existence of different states of matter: solid, liquid, gas, and plasma. I'm not able to hear. You're not able to hear?
Yes, sir.
Right. Thank you. Very good. Sorry. Keep reminding me. Okay. I forget myself when I talk. Right. Please stop me a little bored. Okay. Because I have the habit of talking 3-4 hours. Doesn't it? Okay. Now, what are these liquid crystals? As you are aware, now you have to be very attentive to me. These are technical session. Right. Liquid crystals have their own property. As all of you are aware, solids, they have their own set of properties. Liquids, they have their own set of properties. And the gases, their own set of properties. Now, in order to understand what are liquid crystals technically, let us not waste our time on gaseous systems. Okay? Let us try to understand what are liquid crystals through the important properties of solids and liquids. Okay. Can you tell me few important properties of a given solid? Anybody? Can you tell me? You please think that I am not scientist. I am a common man. Okay? Think that I am a common man coming from Majestic just now. Okay? I am a common man. Okay? Tell me few important properties of solids. Get please. I am a layman here. I'm not a scientist. Give me few important properties. You assume that you are telling something to your father. Tell me. Your father is a scientist? No. Okay. No, you sit down. What's your father? Police. Okay. You are telling something about solids to your father. How do you tell? Don't tell it to the scientists or lecturers or professors. How do you tell?
Solids are something which are very tightly packed.
Thank you very much. Anybody? Boys? You, please. Anybody? Get up here. Get up here. First stand up. Okay. I want you to tell. This is here. You get stuck. You know everything, but you don't know how to put it in a simple manner. That's a problem. Okay. We are not good scientists. We cannot become a good scientist unless you know how to convey your subject to a common man. If I don't do research, that doesn't reach to a common man, it's not a research. It's a waste of money, waste of time. Okay? You know government, how much they are paying me? Huge money. My salary, you can't imagine my salary. Okay? Tell me.
Solids have different shape and volume.
As a father, I didn't understand. Okay, I would say simply, a given solid, when it is taken and when I throw it to your head, what will happen? What will happen? That's the way to tell. Solid hurts you, isn't it?
Yes, sir.
Why it hurts you?
Because it's hard.
There you are. Okay? There you are, right? Solids, they never flow. Yes or no?
Yes.
Simple answer. Solids, a given solid, never flow. Yes or no?
Yes, sir.
It falls. Okay? If I take a solid, it falls, but it never flows. On the contrary, liquids. Liquids? Yes. So these are the contradictory property. Now you understood what are solids and liquids? Given solid, if I heat, with that solid, if I hit you, what will happen? You get hurt. But whereas water, but why? Because a solid is a hard material, whereas water is hot. Right? It flows. Water flows. Solid never flows. Please remember this property. I want you to remember two important properties. An important property of a solid and an important property of a given liquid. Let's start with that. Is it not simple? Yes. A given solid, it could be chalk piece, it could be stone, it could be metal, it could be anything, it could be like this. Okay? Now this solid never ever flows. Am I right or no? Yes. It falls, but never flows. Agree? Yes. Agree or disagree? Yes. Now, talk about water. Okay? What is water? It's a liquid, right? So liquid never falls, it flows, right? So liquid flows, solids do not flow. Remember this. Okay? Now, I have a beaker here. Can you describe this beaker? In what category it falls? Solid. Solid? Yes or no? Yes, sir. No. If I say no, okay, how many states of matter you find here? Okay. Get me water. How many states of matter? You should answer here. Is it boring to you? No. So how many states of matter you find here? You have to be quick. One? Is it not two? Yes, sir. Beaker is a solid. Yes or no? Yes, sir. But air inside? Yes. There you are. That's a science. You look in a different way, but I am a scientist. I should look. I will go beyond that. How many microorganisms, how many viruses, how many algae, all that I will check as a scientist. It's my job, right? So this object is a solid, and also in it we have a gas. Okay. Now, what will I do? If I drop it, what will happen? Break. Okay. If I throw on somebody, what will happen? Okay, let me try. That's good. Okay. This is solid. Okay. It never flows. Now look at water. What is doing? Flowing. Okay. Then basically my question is why? Why a given solid do not flow and a given liquid flows? You take anything, kerosene, oil, whatever it is it not common science? I am not talking something great. Common science, right? Yes, but you don't know how to answer, you don't know how to convince your mother or father what is solid or what is liquid. That's the funny part. Okay? If you want to be a good scientist, you should know how to reach your common man. Okay? Now, tell me, how many states of us? 3. Wonderful. Wonderful. I would say 4. Do you agree or disagree? Total, you see total, in totality. So how many states of matter? You have to be very smart. You have to include me also. So how many states of matter do you find? 4. Tell me what are they? Solid, gas, and plasma. Oh my God. Hey, what are you describing? Madam, they are calling me a plasma. Okay. I am a liquid crystal. Okay. I have in my body, there are n number of liquid crystals. Therefore, you are able to see 4 types of liquid crystals, 4 types of states of matter: solid, liquid, gas, and plasma. Okay. Now, jokes apart, one important point you noted that solid never ever flows. Agree? Yes, sir. Now, I will divide into 2. I am at the center. This part is solid. 1, 2 benches are solid. These 2 are liquids. So, what are your important properties? You solids. Solids, you are solids now. What are your important property? You never flow. Right? Yes or no? You fall, but you never flow. How about you people? Yeah, you should win. Whether this solid wins or liquid wins, we will see now. I am a liquid crystal in between. Okay? Now we will see whether you win or I win. All of us have to win. Right? Okay. What is the important property of a given liquid? It flows. They don't flow, you flow. They don't flow, you flow. They fall, you flow. Yes or no? Yes, sir. Simple. Okay. Why?
Particles.
I'll come back to that. You don't have to answer. I'll come back to that one technically. Okay. I'll just recall your memory. Okay. Now, ladies and gentlemen, there is a state of matter that exists between solids and liquids like me. I'm called liquid crystal. Given the very fact that liquid crystal exists between solid and liquid, it represents the properties of both solids and liquids. Therefore, ladies and gentlemen, you who have, all of you have bundle of liquid crystal. At some point in time, they behave like liquid. At some point in time, they behave like a solid. Therefore, liquid crystal, which represents another state of matter, you can call it fourth state of matter, they possess the properties of both solids and liquids. Okay. Now, what does it mean? What does it mean? It means that they behave like these two benches of students. Okay. They behave like these two benches of students. Now, let's see technically what are they. Okay. Now, I would like to add one more parameter, one more interesting feature of solids and liquids. First, solid never flow. Am I right? Yes. Liquids flow. Solids, there are some set of solids. They are called crystal. Especially, they are called anisotropic crystals. Please remember, solids. There are two types of solids. Yes, there are two types of solids. Crystals and amorphous. Exactly. Okay. There are some crystals which are called anisotropic crystals. Means such solids, they exhibit one more property called a double refraction. You got my point? There is one set of crystals, anisotropic crystals. They are solids. They have one more interesting property called double refraction or birefringence. Remember. So solids, they show birefringence or double refraction. They never flow. Agree? You never flow and you show double refraction, or in other words, you can call it as a birefringence. Okay? Now liquids. Liquids you flow, therefore you cannot show birefringence. Wherever there is rigidity, wherever there is order, in their case, they show what is known as double refraction or birefringence. Very simple. Am I made life very simple? Yes, okay. You do not flow, yes or no? Yes. You do not flow, but you show a phenomenon called double refraction or birefringence. That birefringence experiment I am going to do to you today. Okay? You are also birefringent material. In your body, you have n number of birefringent material. Okay? So, no flow, birefringence. Flow? You need to check what I say. You do not flow, but show birefringence. Is that all right? Yes. Okay. You do not show birefringence, but you flow. Right? You remember this. Now, ladies and gentlemen, liquid crystals. Liquid crystals, in the first place I would like to state the fact that liquid crystals, which represent another state of matter, they flow like liquids. They flow like liquids, at the same time they show double refraction. Whenever you talk about a double refraction or birefringence, there cannot be fluidity. Okay? When you talk about fluidity, there cannot be birefringence or double refraction. Okay? But liquid crystal state of matter is such a state of matter, they flow like liquids, at the same time they show what is known as double refraction. Okay? So this is the important point to be understood. So what are liquid crystals? Liquid crystals represent yet another state of matter. They flow like liquids. At the same time, they show a phenomenon called double refraction. Okay? Fine. Is understood? You have understood this one? Yes. Now this I am going to demonstrate through some experiments. Okay? Fine. Okay, what is matter? Okay, matter is everything around you. Matter is an object that occupies a space and has a mass, visible or non-visible. Matter is made up of atoms, group of atoms or molecule. Why matter exists in different states? It's a very, very important point. I think some of you already mentioned. Please be attentive. The correlation between the constant atom is different, right? The correlation, how they correlate with each other, whether they are sticking together tightly or they are loosely held, depends upon that. Therefore, the state of the matter exists in different states because the correlation is different. I hope you understood what I said, right? As I mentioned to you, all of you are very much, very well aware of the existence of the solid, liquid, gas, and plasma. And now, today I am going to talk to you about liquid crystals. From today onwards, if somebody asks you how many states of matter you know, then you should be able to tell you have solid, liquid crystal, liquid, gas, and plasma. Okay? Except plasma, all the states of matter in your body. You have solid, you have liquid, you have gas, right? So all the states of matter you have in your body. Plasma is also there to a very little extent, don't worry about it. But you are sure that you have all this. So majority of your body is made up of liquid crystals. Okay? 10 to the power of 14 numbers. What is this number? You have how many number of private liquid crystals in your body? 10 to the power of 14. Can you imagine? What is this? Okay? Right. Now, in addition to this, there is another state of matter called Bose-Einstein condensate. So you have Bose-Einstein condensate, solid, liquid crystal, liquid, gas, and plasma. Okay? Let us together tell about the existence of different states of matter. First one. Loudly please.
Solids.
I said Bose-Einstein condensate. Bose-Einstein condensate, solid, liquid crystal,
Liquid, gas, plasma.
Okay. Now technically, in order to understand what are liquid crystals, let us try to understand few properties. I said a given solid never flows, whereas a liquid flows. And also said that given solid exhibit what is known as double refraction. What is this? Okay. Let us try to understand technically. Now here is one experiment to you. How many states of matter do you find here? How many states of matter you find here in the first one? I am going to give prize to you.
3.
3. Who said 3? How many states of matter? I don't know how many are there. I don't know. You have to tell. First panel, how many states of matter? Quickly, please. Name it. What are they? Name. Solid. Liquid crystal. Where is liquid crystal? I am just showing you a small panel here. 3 is the right answer. Okay, solid, liquid, gas. Air is there, ice is there, water is there. Okay. Now, interesting question. So, how many states of matter you find here? Are you sure? Are you sure? Are you sure? How many states of matter you find? How many states? 2 is the right answer because there is a water and there is a gas. Okay, fine. Now, how many states of matter you find here? 1. Are you sure? Yes, sir. That's the right answer. Clever guy. Big round of applause to yourself. How many states of matter? How many states of matter here? 2. Quick answer. There are 2. It is the exact state of gas, lightning, and there is a gas, right? 2 is the right answer, right? Okay. Now, as I said, your body is full of liquid crystals. Without which you cannot digest. This is the RNA or DNA structure? DNA. Okay, fine. So, what I intended to say, your RNA or DNA whatsoever, okay, they have the liquid crystal characteristics. They are called laureate liquid crystals. Is it not interesting? I will talk about it for a while because as far as your health is concerned, you should know how to take care of your health. I kept on mentioning that if you want to be very healthy, you should keep drinking water. What is the reason? Why you should be drinking water throughout the day? Okay? The reasons are very simple. I shall demonstrate what it is. If you know how to drink water, don't worry about food. Oxygen is important, water is important. If you know, then it will be fantastic. Okay? Now, ladies and gentlemen, so far we had some basic idea. Now we now to understand liquid crystals technically, what are solids, what are liquids. As I said, don't worry about gas. In order to understand what are liquid crystals technically, let us try to understand water, solids and liquids. As I said, they don't flow, liquids don't flow, solids flow. Okay, you are alert. I know, you are alert. Okay, fine. Okay, you know three well-known states of common states of matter. Solid is a very, very important slide as far as I am concerned. Solid melts, isn't it? Yes. Ice melts into liquid. Liquid vaporizes to give you gas. Yes or no?
Yes, sir.
Ice, water, steam. Agree?
Yes, sir.
Okay. You can condense it back. Okay, now gas, rain. What is rain? Is the condensation of gas, right?
Yes,
so it comes, condenses, and you have liquid and it's solid is there. During the rain, sometimes we find ice falling. Okay? Ice stones, right?
Yes,
so it is nothing but that representation. Nature you have. Now we don't have to worry about big example. You have rain where you have water, ice species as well as air is there. Okay, fine. Now liquid upon freezing you get the solid. Okay, this is very simple. Means in order to convert solid to liquid, I need to heat. Yes or no? And liquid to gas, I need to heat. Now if I withdraw the heat, gas can condense to liquid, and liquid can be converted to solid state by freezing. So this sequence is called phase transitions. What is called? Phase transitions. Solid to liquid, liquid to gas. Ladies and gentlemen, from today onwards, you should make a place in between solid and liquid. Now solid melts into liquid crystal state. Further upon heating it goes to liquid and then go to gas state. Okay. So liquid crystal exists between solid and liquid. I shall come back to that interesting slide little later. Right. Now I want you to be very attentive. Sit straight, please. So far, you have been able to listen to me about solids and liquids in a very general manner. Now you have to think scientifically. Okay. Now you have to forget about your layman. Come to science. Okay. Now science aspect we will see. Why? My question is why a given solid or crystal do not flow? Answer is very simple. Okay. What is it? Let us try to define what is solid, okay, what is crystal, what is amorphous solid, and what is anisotropic crystal. I think all of you are aware, please listen to me carefully, all of you are aware that, or you have been taught that solids, there are two types of solids. What are they? Right. Amorphous crystals. There are two types of crystals. Further, crystals can be divided into two categories. One is called isotropic solids and the called anisotropic solids. Okay, I shall give some example to you. Okay, I have an anisotropic crystal. So, what is the property of anisotropic crystal? I will come back to that point little later. But in general, all solids, please listen to me carefully. Okay, why a given solid do not flow? There is the answer. A given solid have positional order, or what it is? Crystals. They have atoms or molecules or ions that are arranged very rigidly, as shown here. They are arranged very rigidly, right? So, large intramolecular attractive forces hold them together. Yes or no? Fine. Now, what is the anisotropic crystal? They have crystallographically distinct axes and interact with the light in a manner that is dependent upon the orientation of crystal, that is with respect to the incident light. Don't worry about that. I'll teach you what is it. Okay? How to distinguish between a crystal and anisotropic crystal. Okay, I'll talk about that later. But I think all of you agree, some of you already answered my question. All the solids, they possess what is known as positional order, orientation order. They maintain their shape, they do not flow, they cannot be compressed, they are bidirectional. Yes or no? They have position order, orientation order, very important, then bidirectional. Please remember these three. Okay? What is it? Position order, orientation order, and bidirectional. I shall repeat. You have to, in order to understand what are liquid crystals technically, scientifically, you need to understand that, you need to note down the point that crystals, there are two types of crystals, isotropic, anisotropic. Nonetheless, whatever solid compound you have, they have position order, orientation order, birefringence. Okay? Birefringence is restricted to only anisotropic crystal, but don't worry about it. Now you think that you are talking about anisotropic crystal, they have position order, orientation order, they maintain their shape, they do not flow, cannot be compressed and birefringent. Okay? So given solid, they do not flow, and they exhibit a phenomenon called birefringence. Okay. Now it's very interesting to see what is this birefringence. In everyday everyday life you see it. For example, this birefringence phenomenon occurs in your mobile phone. Is it interesting? What is it then? Okay. Let us try to understand what is birefringence. Okay. Birefringence is very simple. Have you heard about refraction of light? Yes. What is the refraction of light? When a beam of light travels from thin air medium to water thick medium, there is a bending. It's called refraction of light. Agree or disagree? Because there is a change in the density. Right? There is a change in density. Also, the refractive indices change. The refractive index of water is different from refractive index of air. Yes or no? So, density of air is thicker or water is thicker? Water is dense. Okay? Compared to gas, compared to air, the density of water is high. Therefore, there is a bending of light. Okay? So, this phenomenon is called refraction. It is the bending of light ray when it travels from one transparent medium to another. It is traveling from one transparent medium to other. The bending of light is called refraction of light. Now, if I hold a glass of water, half filled, and if I put a pencil into it, it appears as if the pencil is bent. It is not the bending of pencil, it is the bending of light. Therefore, you would get the image as it appears the pencil has bent. Okay? It is because of the light traveling. Okay? Now, what is double refraction? You heard about refraction now. What is double refraction? It is a bending of light into two different directions when it travels through an anisotropic medium such as crystal. It is a result of a splitting of incident light into two. One is the ordinary beam of light and extraordinary beam of light. I shall repeat what I am saying. Okay. Here is a crystal. It's called anisotropic crystal. Okay. It appears very simple. Okay. This is called anisotropic crystal. What it means? This is a special crystal. It's called anisotropic crystal. Such crystals only show what is known as double refraction or birefringence. What it is. Okay. When a beam of light, listen to me carefully. When a beam of light is made to pass through such a crystal, the incident beam of light gets split into two. One is called ordinary beam of light, and is called extraordinary beam of light. I shall repeat. When you take a crystal, anisotropic crystal, when you pass a beam through it, okay. So what does it mean? The incident beam of light gets split into two. One is called ordinary beam of light, and is called extraordinary beam of light, as I showed here. So how to realize it? So this is the birefringent object, a crystal. One light is beam is being sent. Now this light beam, very unusual. Okay, you don't find any other thing other than the crystal, anisotropic crystal. The incident beam of light gets split into two. One is called ordinary beam of light, and is called extraordinary beam of light. Okay. Now their velocities are different. Okay. Here is a crystal. You shall see later during the break that when you have a crystal, okay, when you send a beam of light, there are two lights coming out of it. Whatever you see coming from here to here, there are two-way rays, but you will not be able to see. How to realize? How to see that this is birefringent or not? Now suppose if I put a pencil below this, you will see two images as I shown here. If this crystal, if you put a pencil on the top of it, on the top of a pencil, you put such crystal, you would get to see two images. I said that when a beam of light is being made to send through or made to pass through anisotropic crystal, the incident beam of light gets split into two. One is called ordinary beam of light, and other is called extraordinary beam of light. Now, how to realize? Okay, then you take a pencil, put on the top, you will get to see two images. Certainly, you can do this experiment. You will get to see two images. One image is due to ordinary beam of light, and another beam is due to extraordinary beam of light. I shall repeat. When I take an anisotropic crystal, okay, and below this I will put a pencil. Okay. Now, if you take a glass, okay, put on the top of it, take a pencil, on the top you put a glass line. How many images you will see? Only one. Now, if I put a pencil, please be attentive. Some of you are not attentive. What's happening? Be attentive. I'm a scientist. I'm investing my time. Okay? If you come, then you will not be able to see where I will be somewhere in some experiment. Okay? Be attentive. Okay? I don't know how many times they have requested me to come here. So many times. 3 months. After 3 months, I have come here. Okay? Very difficult to get. Not that we are quite busy with our own experiments. Okay? Please make use of me. Okay? Now, you'll be able to see 2 images, because if you put a glass, you will not see 2 images. Since given the fact that this is anisotropic, you will be able to see 2 images if you put a pencil on the below of this crystal. So now, interestingly, when you rotate this crystal, the image that arises due to extraordinary beam of light rotates with the angle which you rotate the crystal. If I rotate this crystal, one image rotates. That's what is called extraordinary beam of light. The ordinary beam of light follows all the optical laws, whereas the extraordinary beam of light doesn't follow any optical laws. Therefore, if you keep a crystal on the top of it, madam, you are sleeping. Don't sleep. You're sleeping. Okay. When you rotate, the one image rotates. Okay. If anybody finds sleeping, I'll just shut. I'll go. Just go. Is it boring? No. Why are you people sleeping? Okay. Sit straight. Okay. Fine. That's good. That's nice. Okay. Now, with this ordinary beam of light, when it falls on this crystal, it's split into 2: ordinary beam of light, extraordinary beam of light. If you rotate this crystal, what happens? The image rotates. That rotation is due to the presence of extraordinary beam of light. Okay, fine. That is the strength. That is the quality. That is the beauty of this extraordinary beam of light. You understood what I said? Yes. You can set this. Okay. I can do this experiment to you later. Okay, madam. Let them do this experiment. I am keeping it here, but should be back to me. Should not take away home. Okay? It's very expensive. You know what is the cost of this? About 90,000. Only this crystal. Okay? This polarization crystal is naturally available, but the way you cleave, that is very important. Okay? I shall leave it here. Okay? Ladies and gentlemen, now what you have understood, please be attentive. I'll finish quickly. I know that you are hungry. So, what is it? What is it we have learned today? Solids, especially crystals, especially in anisotropic crystal, they do not flow, but they show what is known as birefringence or double refraction. Okay. Now I have to tell you, I have to show how do you examine, how do you feel? Okay, let me put it this way. You have scale. All of you have scale. Yes. Plastic scale. Can you show me? You have line nodidilva? Boys. Allah pari scale kehta hai, scale idea. Okay, jokes apart, give me, right, give me that. So you have a scale, okay, plastic item, forget about scale. You have plastic items at home, CD cover, your plastic sheet, plastic bag, transparent plastic bag, they are all birefringent, right, ladies and gentlemen. All your plastic items are, if they are transparent, they are birefringent. What does it mean? The incident beam of light, the light which is passing through this one, will split into 2. Okay, one is called ordinary beam of light, and is called extraordinary beam of light. So all plastics, they are called polymers. They are polymers, isn't it? They are called stretched or strained polymers. Because of that stretch and strain, they show double refraction. Means the light which is passing through this, you will not be able to see. The light which is passing through this, okay, will split into 2. One is called ordinary beam of light and extraordinary beam of light. Not only this one, any plastic sheet you take, any plastic sheet or scotch tape, scotch tape, any plastic item you take, they are called birefringent material. Means they have the ability to split the light into 2 rays. One is called ordinary beam of light and extraordinary beam of light. Okay, they are quite expensive. Okay, as far as crystals are concerned, expensive, but polymers, these are polymers, they are not expensive. Right. Now, how to check? I said that this is birefringent. Okay? How to check whether the given material is birefringent or not? You have to do a small experiment with the help of polarizers. In your mobile phone, you have two polarizers. What is the polarizer? As you know, when an ordinary beam of light or unpolarized light, when it is made to pass through a polarizer, the vibration of light gets confined to a single plane. Okay? That's called polarization of light. Can you see this one? It's a light, ordinary light, candle light. When I am making it to pass through a polarizer, the vibration of light getting confined to single plane. I am not talking about electrical vector. I shall repeat, what is polarization of light? When an ordinary beam of light is made to pass through a polarizer, the vibration of light gets confined to a single plane. That is called plane polarized light. What is the difference between a polarized light and plane polarized light? Polarized light is the vibration is confined to a single plane. So this is horizontal. See, now I am taking a light passing through a polarizer. The plane, this is called plane polarized light. The vibration of light wave gets confined to a single plane. Okay? This is one way. Now if I twist this polarizer 90 degrees, what will happen? This is now horizontal. Can I make it vertical? Yes, you can make it. That's what I am going to show you today. How to do that experiment. Okay. Okay. So I have polarizer here. Can you see the polarizer? Yes, I will do this experiment. We'll together do the experiment. You should not by heart. Just we'll do the experiment. So these two are there in your mobile phone. In your mobile phone, laptop, computer, whatever it is, television, you have polarizers. Okay. Polarizers can be used to test whether given substance is birefringent or not. Okay, I can do that. Okay, you can test water whether it's birefringent or not. What is birefringent? No, right? It's a flow. It flows. Therefore, it cannot be birefringent. Okay. Now, if I take one polarizer, okay, this ordinary beam of light, it's a vertical polarizer. The vibration of light gets getting confined to it's a vertical state, right? Now, if I rotate the same polarizer by 90 degree, what will happen? You will get horizontal state. Okay, one polarizer, vertical state I can get. If I rotate it by 90 degree, what you will have is right. So, using one polarizer, you can have both states. Okay, just by 90 degree rotation. Now, if I have a polarizer vertical one and horizontal one, if I put on the top of each other, what will happen?
Light will not pass.
Exactly, a big round of applause to him. If I take a polarizer, okay, which has a vertical state, and if I cross it with another polarizer, light gets extinguished. Light will not come out. A big round of applause to once more. The guy who has stand up, please. Why do you think so?
Because it will nullify each other's effect. The same thing happens in a meso compound when there is an organic compound. There takes place in.
I don't bother answers. I appreciate, truly appreciate that answer. Okay, but scientifically, what happens? It's interesting, right? What did I say? If I take two cross polarizer, if I take a polarizer, take another polarizer, cross it. Okay, they are 90 degrees to each other. So what will happen? There is no light. Okay. Now, interesting question. If you are alert, if you are smart enough, you will answer this question. Now, between the two cross polarizer, if I put this scale, I said that the scale shows two. It has two. It produces two rays. Now, if I put the scale between the two cross polarizer, light would emerge or not? Listen to me carefully. Between the two cross, see, this is a birefringent material. What it does it do? When ordinary beam of light is, when a light is made to pass through this object, you will get two rays. One ordinary rays, extraordinary rays. Okay, let's start with water. If I put water with the two cross polarizer, what will happen? Okay, I shall answer to this question, but keep thinking about it. Now, let us try to do it this way, experiments, okay? Now, between the two cross polarizer, if you take a polarizer, if they are horizontal, you will know the light will come out, okay? Now, if I cross them, you can see the crossing. Whenever I do the crossing, there is a dark. Means there is no light coming out. Now, if I completely close it, you will have dark field. That I am going to do the experiment. You have got my point? When two polarizations are crossed, light would not emerge. Okay. Now when I take crystal like this, a scale like this, you see the beautiful color? Can you see that?
Yes, sir.
Yes. This is because these materials have an ability to show, split the light into two, ordinary beam of light and extraordinary beam of light. So the light comes out is because of extraordinary beam of light. Okay? The color you see is because of the interference of ordinary beam of light and extraordinary beam of light. Now in the same place, if I keep a glass, if I keep water, if I keep air, nothing will come out. The light will not come out. Since these materials have the ability to generate one more ray of light, that's called extraordinary beam of light, that emerges. Therefore, ladies and gentlemen, you get to see the beautiful image. Okay? So the color is due to one, you will be able to see the light. That's okay, that's ordinary beam of light. But why do you see the color? It's because of the interference of ordinary beam of light and extraordinary beam of light. With this background, let's go further. Okay? Right. Now, let us talk about liquids. So far, what I have learned? Solids. Okay. Let me go back. Solids, they do not flow. Solids do not flow. They show. Okay. You are solids now. Answer the question. What are your properties? Any one person will stand up and tell. I am going to ask her. Please stand up and tell. What are your properties? You are all solids.
We do not flow, but we show birefringence.
Exactly. Big round for the him. Big round. You are liquid, right? What are your properties? Look at it. Get up. You don't do this. Big round of applause. Yes. Exactly. Big round of applause. Okay. Liquids. Okay. Now you must understand why liquids flow and they do not show birefringence, because there is no position order, there is no orientation order, they do not maintain their shape, they flow, they cannot be compressed, not birefringent. You got my point? A given solid flows, the given liquid flows because there is no position order, there is no orientation order. What does it mean? Technically speaking, in liquids, molecules are loosely held and diffuse randomly. In a given liquid, the molecule tumbles in all possible directions. But that doesn't happen in a given solid. Do you agree or disagree? Yes. Therefore, given solid, now technically speaking, given solid do not flow because there is a position order, there is a orientation order among the chemical species that are present in the given solid. Okay. Now liquids. You see liquids, the molecules tumble in all possible directions. Okay. Contrary to solids, in a given solid, the chemical species tumble in all possible directions. So therefore, there cannot be birefringence. Whenever you talk about birefringence, there has to be order. Yes or no? Whenever you talk, where the birefringence occurs? Where the birefringence occurs? Solids. So solids have position order and orientation order. Since they do not have position order and orientation order, therefore there is no birefringence. Now, with this background, I am almost through with my job. Liquid crystals. Those of you who have still confusion, try to understand what I am saying. Liquid crystal are liquid. They are the phases, special type of phases, unique state of matter. They exist between solids and liquids. Okay. Therefore, they represent the properties of both solid and liquid. Let us see in what way. Okay. Now to summarize, solids, liquids. Look at the correlation between the two, the molecules present in the solid and molecules present in the liquid. In solids, they are held together tightly, right? Whereas in liquid, they tumble in possible directions. So solids, therefore, we can say that they have orientation. We have to say that the orientation order, position order, 3 dimensions, birefringent, no flow. Agree? Yes, sir. Agree or disagree? Yes, okay. Now, how about liquids? Okay, hold on. You are solids now. You tell your property loudly. Loudly, please. Okay, now you. property, and I should take your property also and behave as a very smart guy. I am taking the property of U, and I am giving a special unique state of matter called liquid crystals. Solids, liquid crystals, liquids. Liquids, liquid crystals, solids. Solids, liquid crystals, liquids. Liquid, sorry, this is liquid.
Liquid crystals, liquids, liquids, liquid crystals, solids. Liquid crystals, liquids, solids. Liquids, liquid crystals.
What are your properties? Two important properties, quickly. I flow like liquids. Exactly. Big problems to yourself. Exactly. I'm a very interesting character. I myself is a very interesting character. I flow like, dance like liquids. I'm mobile like liquids. At the same time, why I show double refraction. Whenever you talk about double refraction, there should not be fluidity. Whenever you talk about fluidity, there should not be birefringence. But God has created a yet another state of matter that's truly unique, because they flow like liquids, at the same time they show what is known as double refraction. Can I have water, please? Can I tell you a joke?
Yes,
Are you bored?
Yes.
Truly?
Yes,
Can I tell you a joke?
Yes,
Later. Come to this extreme, okay? Liquids. Now, look at the center. Liquid crystals possess, there are 53 different liquid crystal phases have been discovered hitherto, and Indian contribution is huge. Big round of applause, Indians. Thank you. My dear friends, young scientists, please note that India has contributed significantly in the growth of liquid crystals. Whatever technology you see is because of the Indian research. Let us tell you the habit of we people. We do something, okay, that's very interesting, and you go to your researcher or your supervisor or teacher, hey, what is nonsense, shut it. Oh, it's not like that, okay? Many of the discoveries, I think Indians are leading in terms of liquid crystals. As I said, Professor S. Chandrasekhar discovered discotic liquid crystals, out of which they are making solar panels now. There is a lot of patents are there. We discovered discotic liquid crystal way back in 1977 by Professor Chandrasekhar, okay, by Suresh, Professor Chandrasekhar, and there is Professor B.K. Sadashiva, who is organic chemist. He is no more. They synthesized, and their properties are being well exploited by foreigners. There are many patents, but we have discovered here, we never bothered. Okay, so that's where we are losing many things. You future scientists should be able to cover this, because we are lacking in integrity. Now all of you cannot be organic chemists, all of you cannot be chemical engineers, all of you cannot be physicists. So some group, like you have network now, you have good friends. Somebody has become a chemical engineer, somebody has become an organic chemist, somebody has become a physicist, somebody has become a researcher. You come together. Okay, come together, try to work, and you will be leading. That's what other countries do. I cannot say that I am being a scientist, I know my limitation. I cannot be talking about biology. I know my limitation because I am an organic chemist. I know what I am. Okay, so therefore, I should be able to take the help of gentlemen like him who is doing research in some other area. All these people who are working in different areas come together and do something. Okay, this is what the foreigners do. Okay, with that, let me tell you, as I said, about 50 different liquid crystal pairs have been discovered. They exist between, first and foremost, look at the momentum. Now, solids, there is no moment. Okay, liquids, the molecules are tumble in all possible directions. Whereas in liquid crystal, neither they move, they are not static. Sorry, neither they are static, they move randomly. Right? They are somewhere in between. You can see molecules, they are going up and down, but not a single molecule is tumbling down. It's tumbling, it's not tumbling, right? It's going up and down, up and down, up and down. Okay? So this is what exactly happens. Okay? They have some order. There are some partial order and fluidity as well. Okay? This is because they have orientation order. Please note, some of them also have what is known as position order in 1 or 2 dimensions only. This is your life. If the order goes in 3rd dimension, you will be dead body. The order should not go. This can be done with the help of water. Okay? When you don't drink water, some of your system goes to third dimension. You should make sure that you are in 2 dimensions. Okay, I will come back to that point later. Okay, finally, liquid crystals represent yet another state of matter. We shall call it 4th state of matter. They flow like liquids. At the same time, they show double refraction. I shall repeat. Liquid crystal is a unique state of matter. They flow like liquids. At the same time, they show bifurcation or double refraction. Now I want to do experiment. Okay, I have to show you, right? As a scientist, I have to show you that this is the case. Now, to show, what should I do? In liquid crystals, what should I show you? I have to show you double refraction and mobility, right? In water, I have to show you only mobility. In crystal, I have to show you only double refraction. Yes or no?
Yes, sir.
Solids, they show double refraction, no mobility. Liquids, mobility, no double refraction. But me, I'm Sharma. I'm Rajkumar. Okay. You will like that.
Mobility and double
Mobility and well done. I'm really happy. You understood. At least some of you understood. Big round of applause to yourself. For a while you just block it. I would have to do experiment. I am not going to do experiment. You are going to do experiment. Okay. You lost your energy.
No, sir.
I should be losing energy. I am went on speaking, right? Very. Now you are going to do the experiment. Very beautiful experiments. Okay. You have card on the board it today or a while so that it will block. I don't know that. I like everything from this.
You can just read it up.
Hey, should be other way around. Madam, I am really grateful to you. You did this. Really grateful to you. ನೋಡಿ ಆನ್ ಆಗಿದೆ ಅಂತ
ಮೈಕ್ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿದೆ, ಮೈಕ್ ಕೇಬಲ್ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿದೆ. ಅವ್ರು ಕಾಲರ್ ಮೈಕ್ ಯೂಸ್ ಮಾಡ್ತಾರಲ್ಲ ಅದು ಆಫ್ ಮಾಡಿದ್ದಾರೆ. ಬರ್ತಾ ಇದೆ ಕರೆಕ್ಟ್ ಅಲ್ಲಿಂದನೇ ಬರ್ತಾ ಇದೆ.
Okay, first I want a volunteer who can do the experiment with me. Who? You come.
ಮೈಕ್ ಆಫ್ ಮಾಡಿದೆ ನಾನು. ತುಂಬ ವಾಯ್ಸ್ ನಾನೆಲ್ಲ ಟ್ರೈ ಮಾಡಿ ನೋಡಿದೆ. ಅವ್ರು ಬಂದು ಹೇಳೋದ್ರು ನನಗೆ ಕೇಬಲ್ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗಿದೆ, ಮೈಕ್ ಆಫ್ ಮಾಡಿದ್ದೀವಿ, ಕಾಲರ್ ಮೈಕ್ ಯೂಸ್ ಮಾಡ್ತಿದ್ದಾರೆ ಅಂತ. ಅಲ್ಲಿ ಸೌಂಡ್ ಪೋಡಿಯಮಲ್ಲಿ ಇಲ್ಲ, ಅಲ್ಲಿ ಬರೋದು ಮೈಕಲ್ಲಿ ಏನಿದ್ರು ಬರ್ತಾ ಇದೆ.
Where is madam? You have to show, I want to show her the experiment. Madam. Shobha madam. Important. Okay. Now what did I say? I said nothing, right? I said nothing, is it? Madam, sit down please. Okay, let's do small experiment, okay? Now I have polarizer. You and put on the projector. Okay. Can you see the light?
Yes.
Okay. It's a polarizer. Okay. The piece you see here, there's a polarizer. This piece is plain polarized light. Okay. If there is vertical or horizontal, let us not worry. You see, this piece is called plain polarized light because it's emerging from where? Polarizer. Light is crossing polarizer. Therefore, it is called plain polarizer. Can I have one more paper, please, to cover this? Okay, take that cover. Okay, great. Okay, now he is going to put. Can you see that? This is a plain polarized light. Okay. Yes or no?
Yes, sir.
Okay. I am going to put one more polarizer. This polarizer, repeatedly saying it will be there in your mobile. Okay. Fine. Take this polarizer. Okay. First, he will put it in a parallel way. Okay. Light is coming out. Right. Now he is going to cross it. Slowly rotate. Slowly. Yeah. Are you married? Slowly. I think you are married. Okay, slowly. Scientists don't tell lies. Right? Yes or no?
Yes.
How do you tell lies? I'm showing you. Whatever I said, I'm showing you. Right? Okay. Rotate again. Okay. Well done. It means that he is not married. No. Okay. Jokes apart. Yeah, I'm just joking here. Okay. Whenever you talk about marriage at this age, it's quite interesting. We only know married people. Okay. We only know what's going on. Jokes apart, right? And they are twins. You know, at home, you know that, right? Who always wins? Mother. Father is sitting in somewhere new. Okay, remote control is always with mother. Look at it. Okay. Are you married? Huh? That's why it's like this. When did you get married? 8 months back. But jokes apart, just a joke. Okay, now between the two cross polarizer, which kind of matter is there? Tell me quickly. Between the two cross polarizer, yes, exactly. Who said that? Okay, very good. Big round of applause for him. Once again, confirm that he is not married. Jokes apart. Now there is air. Air is not direct emission. Now, ladies and gentlemen, if I put any direct emission material between the two polarization, what will happen? Yes, exactly. Now, which is my best direct emission material? Very expensive. 1 lakh rupees. Scale. Right? Okay. Now I have something else. Where is that scale? Okay. What is this? CD cover, right? Okay, what is this? K. Now, between two cross polarizer, if I put it, what should happen? Light. Man. Okay, take this. Okay, put it there. Put it there. Are you? Okay, now, can you see anything here? No. Now, what are you expecting? Light. What are you expecting? Light. So? Light. Along with that? Color. Because the light will come out. It's because of the emergence of extraordinary beam of light. Who doesn't follow any optical law? Along with that, you should have color. Color, right? If you don't get, they'll shout at you. Your eggs are ready? Tomato ready? Okay. Cross it. Cross it now. Are you? Can you see that color?
Yes, sir.
Big round of applause, please. You are appreciating phenomenon, not me. Now, she showed that. Okay. Yeah, is it okay now? Yes. Ladies and gentlemen, please note there is emergence of color between the two cross polarizer. When I put a biphoton material, there is emergence of light. But this is not this is ordinary light, but there is interference of ordinary beam of light and extraordinary beam of light. Therefore you have color. Okay. Now if I replace this with somebody else, please go. Okay. You have to give me 20 rupees. 20 rupees. Each expense 20 rupees. 40 rupees. Because I don't do anything cashless, only cash. Okay. Scale. Right? Would you be too important? Scale important ನಿಮಗೆ ಯಾಕೆ ಹೇಳಿ now women are coming forward. Jokes apart, now you see whether you get the color or not. Cross. Now there is air, agree? Now there is solid, right? Air do not flow. Sorry, air flows. Air diffuses. So air diffuses means gaseous state diffuses. Whereas there is a solid, it shows bifurcation and it is not flowing. Now, if I put water between the two, what will happen? Now let me put water. Who is going to come on next? Okay, last somewhere. That please come. You come. You only. Come this side. Okay, between the two cross polarizer, I am going to put water. She is going to put water and so it is going to give color. Am I right? What should water do? Okay, come here. Okay, now she is going to put water. Get me water, some water please. Okay. Just take, come here. Okay, now between the two cross polarizers, she is going to put water. Okay, what do you expect? You only know. I don't know. Water, if I put between the, what happened when I put the scale? Okay, glass is not showing anything, right? Now between the two cross polarizers, when I am putting a scale, it shows bifurcation, but there is no flow, right? Now you put water, what should happen? No color. No color, no light, no color, but flow will be there. When I put a scale, there is a bifurcation, but there is no flow. I shall repeat. When I put a solid substance, there is no flow, but there is a bifurcation. Am I right or wrong? Yes, sir. Now if I put water, what should happen? No bifurcation, but there will be flow. Okay, that's what I am showing, right? If it doesn't happen, eggs are ready? Yes, sir. Come this side. Take small amount of water. Or leave your hand. Yeah. Very dirty girl. One more. That will be dirty. Put just one drop here. One drop. Just one drop. Yeah. Can you see that? Yes, sir. Put down this. Dirty girl. put on the top. Very good. Can you see the mobility?
Yes.
Now, if I put this, place the two cross, what should happen? Have I demonstrated? Yes or no?
Yes,
Solids, when I put them between the two cross polarizer, they light the allowed to come out and there will be birefringence. Okay? When I put liquid between the two cross polarizer, there is a flow, but there is no birefringence. I shall repeat: solids, no flow, but birefringence. Liquids, flow, yes, birefringence. Right? Now, sit down. Are you married? Okay, now, who will come to the final experiment? Who will come? Okay, back side. Okay, let's do one thing. Madam, you come. Have I taken right decision?
Yes,
Because she is important. She is important, therefore experiment is important. Okay, now I have put all the three. Okay, you have tissue paper. Tissue. I have some tissue. Okay, now madam is here. This is a liquid. Okay. Okay, this is liquid, right? In liquid, what you saw, mobility you saw, no birefringence. In scale, you saw birefringence, no. Now, in between, we are going to put liquid crystal. What do you expect? What do you expect? No and birefringence. All the rest. Okay. Now, here is a liquid. Okay. Here is a liquid crystal. This is used in all your display. Can you see this liquid crystal?
Yes, sir.
Can you see that?
Yes,
Neither this is transparent. Can I have lights, please? Lights on, please. Or I will just lights on, please. Lights on. Yeah. Can you see this? I don't know how to show it. Can you see this? It is neither like a water, not like a solid. You can see the fluidity. Can you see that? Yeah? Can you see that? It's like milk. Okay? But milk is not liquid crystal. Okay? Okay, fine. Now, madam will show you what will happen if you put the liquid crystal between the two cross polarizer. Madam will put a drop here. This sample we supply to some companies, LG. Okay, they use it. Sony, LG, everything. Everybody use this. Okay. So between your all your LCD, mobile phone, everything, they compress this. They are nothing but organic molecules. Water, liquid crystals, thermotropic, organic molecules. Just a drop. Just a drop. Okay, can you see that?
Yes,
okay, it's not like water, right? Okay, madam, put this one quickly. Can you see the mobility? Yeah.
Yes,
Madam, you put this now. See that mobility? Can you see the mobility?
Yes,
That is the wonder. That is the unique property of liquid crystal. Big round of applause. When you put a bioelectric material which is solid, you do get to see color because of the origin of the extraordinary beam of light. Because of the interference of the ordinary extraordinary beam of light, you get to see the color, okay, in solids, but they don't flow. When I talk about liquids, they flow, but they don't flow. When I put liquid crystals, can you see that? They flow like liquids, at the same time, they exhibit what is known as bioluminescence. I think I am done. I so far have been able to demonstrate, to convince you that with experiment, liquid crystal represent yet another state of matter. They flow like this. Thank you very much. Thank you. Those who have involved in the experiment, thank you very much. And those who are also involved in question and answer session, thank you very much. Okay, now panel liquid crystal represent yet another state of matter. They flow like liquids. At the same time, they show what is known as bioreactions. Madam, can I take another 10 minutes? Am I?
Yes,
Am I allowed?
Yes,
Now, this I am going to show you how display works, how it is in your mobile, how it is, how the displays are. They are very big. Okay, how the liquid crystal display works? They are nothing but organic molecule. What I showed is organic molecule. Okay, how it works, how it is made. Okay, you want to see a display how it is? Yes or no?
Yes,
Is it really big? No, it's big, really big. I asked my staff to bring it, and they'll bring it now. We'll wait for 5 minutes. Okay, then I'll show you. It's a really big one. Okay, what is the big one? Display is very big one. Okay, it looks very big. Ta-da-da. Display? Okay. Can you see the display? It's called liquid crystal display. Can you see this is so small? This is put in petrol bunks. Okay. We have made this. As I said again, from our center in association with the Bharat Electronics Limited, BEL, we made huge numbers. Throughout India, we supply now. Big round of applause for. Male teacher, he represents one male. Both of the poor guys, man. Okay, these are the segments where you can put the connections. There will be small sockets in your mobile. They called matrices. Matrix are there, very small square. Okay, how it works I'll tell you. Are you interested or no?
Yes,
5 minutes, okay, few minutes. No problem, this is good. Okay, I'm going to put the connection, okay. One end, it's just a small battery, okay. Small battery, okay.
ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀನಿ ಅಲ್ಲ ಅವ್ರು
So he is going to give connection now. See what happens. Are you able to see?
ಮೈಕ್ ಆಫ್ ಆಗಿದೆ ಅದು ಒಂದೇ ಬರ್ತಾ ಇರೋದು ಒಂದೇ ಬರ್ತಾ ಇರೋದು
Can you see that? Can you see that? Okay. If I disconnect. Okay, it will vanish. No, it's not like that. It takes time because you are disturbing it. Truly, liquid crystals are very sensitive to sound temperature. Okay, so they are put in a condition that sometimes if you take your mobile phone outside, what will happen? You will not be able to see because they would have going to the liquid state. Okay, so put one more. Can you see that?
yes,
So this display works. Okay. Now I am going to teach you how to make display at home. Will you make?
yes,
Shall I teach you?
yes,
They will throw me out another half dozen days. Okay, fine. Now, two things you should understand. In your display, liquid crystal display, you will see two orientations of the organic molecule. The orientations are such that if the molecules are lying along the glass substrate, this is a glass substrate, it's a glass. They are put on the glass. If they are sitting along the glass substrate, what will happen? That is a bright state. Okay? You know that how the images are made in your mobile is a combination of bright, dark. Only two. The combination of bright matrix and means dark and bright state together that will form the image. Okay? What is only two? Bright, dark and color. Okay? Now if the molecules, organic molecules are lying this, okay? Now it is like that. Okay? Molecules are lying like this Therefore, you get a bright state. Okay. Now, if I apply electrical field, sir, apply electrical field in this particular direction. Now, the molecules, organic molecules, are lying like this. That's a bright state. When you apply electrical field in the perpendicular state, perpendicular to the glass of state, they orient like that. Organic molecules which are sleeping, they stand up. When they stand up, you will get dark. Okay? Because the molecules are along the optic axis. Simple principle. In all your mobile phone, you get images. That is nothing but the combination of dark and bright segments. Okay? Dark and bright segment. Depending upon the current flow inside, because you showed them the current, right? So when sir apply current, you will have a state. Okay? So all these displays, when it goes thinner and thinner and thinner and thinner, and you have the number of patterns increases, the price increases. You know that you have a mobile up to 6 lakhs, starting from 50 rupees. Am I right? Hey, come on. 50 rupees, I can get you. 50 rupees, China made. Sorry, I don't know. So, okay, I mean, now it has become so cheap. Okay, now it all depends on what kind of, you saw the response. How thin it is, what kind of organic molecules are used, and what is the speed of this display. So it will all add to the cost. Now why the mobile phones are so expensive and they are also cheap? It all depends on what kind of organic molecules are using. So there we come into the play, we come into the picture. Organic chemist, we know how to synthesize molecule. We make the molecule very cheap. Either can make molecule very cheap, they don't have property. Okay. When you expect a quality, there will be some kind of restriction. You know, whenever you talk about quality, okay, price will go up. You know that mangoes, for example. Okay, varieties of mangoes you have. Anything you take, quality is there, price will go up obviously because demand is huge. Okay, likewise in mobile also, depending upon how thin your mobile is and what kind of organic molecule you are using inside, is nothing but organic molecule. What I am showing is organic molecule. Can I draw the structure? Yes, I can draw the structure. They are called cyanobiphenyls, okay? Terphenyls or cyanobiphenyls. Cn, okay? OCN plus 1. Okay, n is equal to, it can be 2 up to 22, okay? Right, so we also use terphenyls, fluorinated compounds. This is a mixture of fluorinated and whatever it is. You can have fluorine solutions here, or you can have here, whatsoever. So these are simple 2-ring or 3-ring organic molecules that constitute this organic. These are all organic molecules. They are all the mixture of those kind of molecules. Okay, they are fluorinated biphenyls or terphenyls. Okay, that's what we synthesize. Okay, depending upon the synthetic process, we have a patent. How quickly you can synthesize, how cheap you can synthesize, that's all patented. Okay, fine. This is as far as the thermotropic liquids are concerned. Madam, can I take another 5 minutes? But they will be angry. Okay, remove this. I want to show a few slides and then wind up. Can you give me another 10 minutes, 5 or 10 minutes?
Yes, sir.
Okay, then I would like to present one very nice joke. Can I?
Yes, sir.
Then sit straight. You know Einstein?
Yes, sir.
You know Einstein?
Yes, sir.
Okay, after his Nobel Prize, he used to go. You know that whenever you win Nobel Prize or something, you have to go and give talks. Okay. You know that those days, getting a car itself was very difficult. Okay. Einstein had a car, and he is very typical man. You know Siddharth is, and he is very typical man. Okay. Extraordinary brain. Till today, I am a big fan of Einstein. Okay. I read about him a lot. Okay. Because he is a very peculiar man. He was not able to calculate 2 plus 2 is equal to 4. He used to write 5. But his chemistry was super. Other things are very. You know that. He was expelled out from the class. All that you know story, right? Simple things he could not understand, but the very complicated things he used to present. Okay. You know that Einstein was a big scientist and he used to give presentation after his Nobel lecture. Okay. He used to go give presentations, and everybody used to call him. And on a term basis, he used to go to different colleges, different research institutes, and present talks. Okay, and his driver was very smart, and he only driver. Okay, driver and this guy. He used to talk to himself, and driver used to just say yes or no, it can be. By the time it was over, the driver had become another scientist. Imagine. When the way, if I keep talking about liquid crystal now, I made you to spell it out. Okay? If I hammer you like that, then obviously it will come out. Right? It has to come out. Right? It has to come out. Okay. Like that, you used to go here and there, here and there, here and there, here and there. One fine day, what happened? Previous night, there was some big party. Okay, I don't know what happened. He took too much of cold beer or something like that. Why was it? Cold beer. Okay, you will get obviously flu or something like that. He was ill. Totally, he was ill. He could not even open his mouth because he could not speak because there is an infection. Okay, he was unable to speak. What to do? It was one of the. I will not take the name. It is one of the best research organizations in the world in Germany, and he went there. He has to give presentation because there were another set of Nobel laureates waiting for him. But those days there is no photography, no television, nothing. Nobody knew. If I say he has to believe if I say I am Einstein because there is no photograph. Okay. Now if I say Yelamaggad, already my print is here. Nobody can replace me, right? Since they are printed, I should come here. I cannot send my assistant here, right? So what happened those days? There was no communication. Okay. 11 o'clock he has to come. He has to present a talk. After the lunch, he will go to his institute back. Then what happened was he was unable to open his mouth at all. Totally not able to even speak. Then by doing something, what is it called? Not talking much, he converted the message to driver. You become Einstein, you are my code, I'll become driver. Okay, they went. Fantastic idea, they went. Okay. This driver used to go to each and every lecture hall, attend his lecture and come back because he has to hold his bag. Okay, every time. Only few people know who is the one who they know is a driver, he is Einstein. Those where they have given the talk. Otherwise, nobody knew. This driver, stylish guy, he had everything in his head. He presented as if he were to Einstein. He presented talk in such a way that because it was imbued in his mind, it was already printed in his mind. A to Z as it is. Okay? He presented the talk as if he is more than Einstein. Okay? While everything went off well, one Nobel laureate stood up, asked a question. He's a driver, what can he answer?
My driver will answer.
Huh?
My driver will answer.
Okay, then he was very angry. Very angry. His driver was very angry. Einstein was very angry. Then, you stupid, you don't know such a silly answer. Sit down. Ask my driver, I will tell you. Okay, there is no. Driver, who is the driver? Yes, answer. Okay, quickly, another 5 minutes. Okay, right from the beginning, I told you why one should drink water. First statement was, all the living beings are composed of n number of liquid crystals. We started our life with any living system. Whatever it started, the living beings, we living beings are here on earth. Everything started with one cell. Do you agree? Yes or no? Yes, one cell became 2, unicellular, bicellular, tricellular, tetracellular, multicellular. We are multicellular, right? That's how the life evolved. Okay. Now, I said whether it's unicellular system or multicellular system, amoeba or dinosaur or tiger or elephant, all of us are composed of n number of liquid crystals. If it is one, if it is amoeba, then you have one liquid crystal. If it is two liquid crystals. So, how many number of cells you have? Multi numbers, right? Each and every cell is liquid crystal. Agree? Why should you agree? I should demonstrate that. Not the cell, that's a general word. You know that cells in our system we call plasma, right? Cells of any living system are very well protected by what is known as cell wall. Am I right? Cell wall. Cell walls are liquid crystals. Cell walls are liquid crystals. Forget about DNA, RNA and other things. Your each and every cell, you have a number of cells? You have cell or no?
Yes, sir.
Do you have?
Yes, sir.
I'm surprised I don't have. You are composed of a number of cells, right? So these cells have been very well protected. Their functioning. This function is because of the fact that they are liquid crystals. At some point in time they behave like a liquid. At some point in time they behave like a solids. Okay. Now think of division of a cell. If cell has to divide, isn't it? Every day it happens in our body. If cell wall is to be very strong, like a wall, cell division cannot take place because it is a mobile, right? It's a fluid. Cell wall is a fluid. Therefore, there is a division. Now, you know that if you want to communicate. Now, if I want, you want me to lift my hand, madam, you ask me, I lift my hand. Sir, you lift your hand. But tell me, why should I sit down? Why should I? Now, I will tell myself, Dr.Yelmaggad, can you please lift your hand? What is it? It means that the communication, there is a good communication between your brain and your part of your body. What does it mean? It's a very simple message. It means that one big thing, that is very interesting thing happens in your body is that your each and every function, each and every cell, that means each and every cell is being very well controlled by brain through a process what is known as neurotransmission. Neurons are generated, right? There is a neurotransmission between the brain and cell, which it goes to cell. Cell is a part of the tissue, right? So there is a communication between brain and particular body. So this is through what is known as neurotransmission. Means what is neurotransmission? What are these pulses? These are nothing but electrical signals. What is epilepsy? That is uncontrolled production of pulses, electrical pulses. See, if you want to lift my hand, there is electrical pulse generated in my hand, in my brain. So my brain communicates to this neurotransmission to lift your hand. If a mosquito bites you, you will not sit quietly, right? This is neurotransmission. Okay, this is called neurotransmission. What it means? It means that your brain produces electrical signal. That electrical signal has to be fed to a cell. Okay? It means that cell behaves like a metal. Agree? Cell division, it has to be like liquid. In order that it receives a signal from the brain, it has to be like a solid. It means that cell wall at some point in time behaves like a liquid. At some point in time, you behave like a metal. Do you agree?
Yes,
so
sir.
this is the quality of liquid crystal. Okay? Liquid crystal, they flow like liquids, at the same time they show birefringence, means they conduct electricity. Okay? You saw that. Yeah, they are mobile, they are fluid, but they conduct electricity. So that is the beauty of your cell. Okay? Let me go through quickly. This I have done it already, I don't know how to do it. Okay, liquid crystals, they flow. They are birefringent, they are optical instrument. Don't worry about that. Okay, as I said to you, is a liquid crystal is in state of matter. There are two types: allotropic liquid crystal, something to do with our life; thermotropic liquid crystal, something to do with your technology. Okay. Now, this don't worry about it. Let's go to straight away. Yeah, life and life processes are typically based on liquid crystal behavior. That is, liquid crystal behavior occurs in DNA, protein, tissues, and cell membrane. Okay, you have n number of liquid crystals in your body. So life starts with cell membrane. Okay? Okay, my question is my baby, don't look at it. Don't look at it. Okay, listen to me. Now, in order that a cell has to be formed, what has to be formed first? Quickly, any biology professor here? In order that a cell has to be formed, what has to be formed first? Generation of a cell. Cell wall is formed, am I right, professor? Any teacher here? Biology teacher, no? Okay, I am a biology teacher today. Okay, in order that a cell has to be formed, first the cell membrane has to be formed. Okay, listen to me carefully. What is cell membrane?
Boundary.
What is cell membrane? Technically, this is a liquid crystal, right? It means that liquid crystals are formed first, everything started. Okay? First there is a formation of cell membrane, then organelle, cell, tissue, organ system and whole organism. Okay? Means everything starts with liquid crystal, it means. Okay? Therefore, you have to repeat the word to liquid crystals. Everything starts with liquid crystals. Okay? Everything your life is based on liquid crystals. I think now you are getting the point. Why ask you to drink water? Okay? Right. Now you see cell membrane. Human have about 100 trillion organic cell. You see this is a cell. There is a cell wall. Cell wall is nothing but this is the bilayer. Okay? Within the cell there is a water. Outside there is cell water. Okay? Cell has to maintain fluidity. Please understand this is a very very important point. You are not supposed to remain thirsty. Means this cell membrane has to be between the water. Okay? Outside there is an inner world, there is an outer world. This is cell content, this is outside the world. So it is as good as putting a leaf over water. Okay? Inside there is a water, outside there is a water. Okay? So it means that your cell should be floating in water. Inside there is a water, then outside there is a water. Those who have the habit of drinking water, they keep it fluid, they keep it wet. If your cell membranes, okay, what is aging? We scientists believe that, especially I have proposed a theory, that this theory has become very popular. Okay, what I have said is, my definitions are very simple. Aging is nothing but continuous loss of water. It's a systematic loss of water. Let me demonstrate. What is aging? Aging is nothing but loss of water. If by some means, if I am able to hold water in my body, I will remain young forever. It's true. Demonstrated. For example, water in newly born may be 78%. Okay? Don't I'll come to that point. Okay. Babies have 78% of water, but by the time it goes by 1 year, the loss of water is about 30%. Okay? Listen to me. Then I'll join you for the law. Okay. I'm also mad like you. Right. So it is 78%. Listen to me, this is the point. 78% by the year, the newly born baby, I know when I was holding my son and daughter, I know how they were. When they were born, they gave it to me straight away. Because my wife was unconscious, they gave it to me. Okay? I know how beautiful they are. Okay? The moment they born, I know. I have both experience, my son and daughter both. And for 8 days I am holding them because my wife is not well, both the time. Okay? But when they are born below 1 year, you cannot explain. Babies, I know, all of you know. But the time they grow by 1 year old, there is a loss of 78%, 30% of water, then everything starts. I am here now. Okay? I look so ugly because there is no water, simply water. Your skin, texture of your skin is different to me, is simply water. Content of water, okay? The way your skin holds water is different from the way my skin holds the water. Okay? The quality of holding water comes down because every organic molecule has shelf life. Okay? Therefore, your cell membrane has shelf life. So after some time, it loses its mobility. Okay? But those who have the habit of means, as long as this lipid bilayer is liquid, fluid, you are healthy and you are young. As you grow old, this becomes solid. Now, when you are born, your cell membrane is perfect liquid crystal. When you start growing old, this liquid crystal cell membrane now move towards solid. Now, my cell membranes are almost solid. I'm 58. My cell membranes are almost solid. Your cell membranes are comparatively liquid. When you compare, maybe you are already processing, you are towards death. What does it mean? Your cell membranes are going from fluid state to solid state. You can slow down. You can slow down this by simply drinking water. Those who have the habit of drinking water, they survive long. No doubt. Okay? No doubt, because I'm the best example, I'm surviving. Despite the fact that I was exposed to many chemicals, dangerous chemicals, sodium cyanide, so many toxic gases. I have done the experiments. You have seen our lab, right? How difficult they are, okay? But I have the habit of drinking water, okay? I've given the example of Shiv Kumar Swami, right? So he used to drink lots of water. Early in the morning itself, he used to drink water. I'm done. Ladies and gentlemen, please be attentive to this last statement of mine. Please keep drinking water throughout the day. If you want to remain healthy, keep drinking water throughout the day. You should finish at least 3 liters of water per day. Okay. Besides this, those who are suffering from mental illness or those who are having problem with their thought processes or some kind of a problem, okay, it's very difficult to balance. Okay, sometimes thoughts very difficult to balance, or I don't know how to say about it. But there is some kind of a disturbance in the mind. For those who are having this problem, please start drinking water early in the morning. Even generally also, if you drink water early in the morning, what, half lemon or full 1 lemon? I take full 1 lemon. Okay, 1 lemon, a small piece, a bit of jaggery, not jaggery, brown jaggery or honey, warm lukewarm water, just gulp before drinking your tea. Then 45 minutes you don't take, you will see that your skin or hair, everything start glowing. Okay, first and foremost, what it does is it wets your cell membrane. Basically, you have to protect the health of the cell. By taking oxygen, you are providing oxygen to your cell. Am I right? By eating, you are providing nutrient to the cell. It goes through blood. By drinking water, you are providing water to the cell through blood. Yes or no?
Yes, sir.
So keep your cell membrane wet all the time. Don't make it dry. I strongly suggest and recommend not to remain thirsty. If you remain thirsty by 5 minutes, you will be losing 6 hours of your life. If you remain thirsty for 5 minutes, you will be losing your life by 6 hours. Okay, so that's the calculation. It's all our anticipation, our calculation, nothing else. There are no evidences, but I have the evidences. Shiv Kumar Swami or people like me, the old people, they know how to drink water. Okay, you can see old people, they drink a lot of water. Yes or no?
Yes, sir.
Okay. Ladies and gentlemen, today I was able to talk to you about, I hope I have conveyed the message that liquid crystal represent another state of matter. They flow like liquids. At the same time, they exhibit what is known as double refraction. With the experiment I have demonstrated, and please see that your father or mother or grandfather or whosoever it is, please see that you also keep drinking water. Now, today onwards, do you promise me that early in the morning you drink water?
Yes, sir.
Now, today onwards, 1 liter water doesn't matter. I know that when college is going on, every time you cannot say, okay, that is difficult. But you try to see whether you can drink water. Okay. Whenever I go to any organization, I convey this message so that you remain healthy. I think I conveyed the message. Nothing more than your health. Please take care of your health just by drinking water, nothing else. Okay. And one more message is, don't gulp paracetamol. Very toxic. Okay. What is paracetamol? Kerosene. Should not take paracetamol. He said you can drink hot water. You remember, sir, when we were kids, they used to put a small piece of cloth with cold water. That is the best medicine. What is called fever, it used to come to control. Body is okay, but should not go to brain. That's why they used to put a small strip here. Don't take. I know that nowadays this kerosene has become. COVID time it is very famous. Ragi mudde, very popular. Okay, but that has killed many people. You know, Doro 650 killed many people. You don't know. Now there is statistics. Because of Doro 650, many people have died. Okay, this is very toxic. What is the best medicine? Keep drinking hot water when you are ill. Keep drinking hot water when you are ill or have the habit of drinking water. Don't drink cold water, please, anymore. Don't drink cold water. Refrigerated water is very bad for health. Very, very bad for health. Okay, it will kill you. Okay, I have a demonstration. I can prove why I am saying like that. Okay, Do you promise me that are you taking care of yourself?
Yes, sir.
So today what are we talking about? Chemistry, physics, biology, right? We talked about all it. I wish you all the best. Take care of yourself. Let's go through this slide. Let's quickly go to cell division. Okay, I told you that the cell is like plastic. Okay, it is like a rubber band. You can see this. You can stretch it. Okay, I talked about cellular neurotransmission. Okay, you can see this how signals are in your body. All the time signals will be going through neurotransmission. Right? Okay, don't talk about all this. It's all very interesting. By the way, do you take bath every day?
Yes, sir.
You take bath every day?
Yes, sir.
Surprise, really something. I take only in the morning. So when you mix water, when you take bath, what do you do? Get in the bath, what do you do? Wet your body, take a soap case and roll. The white thin film what you get is liquid crystal. Okay, that liquid crystal is very complicated structure. You see, when you take bath, this is the process. You generate so many structures on your body. They are called diatropic crystals. Just simply go and take bath. Over. But you know how many complicated structures are generating in your body? These many. Solid, liquid phase, liquid. There are 4 liquid phases, one micelle and homogeneous solution. Okay? You are never bothered, isn't it? How should you bother? You know how you are clean? Because of liquid crystals. You are framed of liquid crystal. You are protected by liquid crystal. Your entire entertainment world is liquid crystal. What else you want? What else you want? Right? Okay, okay. I'll show you quickly. Yeah. Can you see this strip?
Yes.
Yeah. Can you see the temperature now? Can you see the temperature?
Yes,
It's about 25 degrees. There is no connection, nothing. It's a liquid crystal. It's a strip. Can you see the strip? At 25 degrees. Can you see?
Yes, sir.
Okay. Now. Sir, let's see how hot it is. You want very hot? Yeah. You are hotter than me. So they are called thermal sensors. Okay, we made it our institute. Okay, you don't have to have now. Strips are available. Just put on the forehead. You count down the temperature. These are called. Are you not realizing that the liquid crystal is already into technology? Can you live without? I can live without my wife, but not without my mobile. Am I right, sir? Yes or no? Yes or no, sir? Can you live without? Very hot here. Okay, so these are thermal sensors. These all have different applications. We use it in mental health patients. Okay, what we do is like that. What we do is to mental health, mental ill person, we put a strip there. Whenever there is change in temperature, we treat them. Okay, like that. There are so many. By the way, this is the we all liquid crystal people are surviving because of this. Thanks to all the gloves. Half of my salary goes to this one. I cannot do that. My daughter is there. Okay. Jokes apart. Now, all your cosmetics is a big world. You don't know. You know what is the business? My God. You are not the gold sells like that. Very big business. Can you hear me now?
Yes, sir.
Okay. Now I will give a tip. If you go to market, see that they are liquid crystal based. Use lipstick or your bindi, whatever it is. they are based on liquid crystal. Don't kindly use lipstick other than the liquid crystal based. Liquid crystal based means it is scientifically proven. If you use liquid crystal based cosmetics, you are safe. Okay, kindly do not use other than they have written it is a liquid crystal based. Okay, these are all liquid crystal based. Okay, right. Why? A car, you have a car. Okay, something happened in US, that's why you drawn. Morning you will have this pink color. In the afternoon at about 12 o'clock, black. In 2 o'clock it is red. At about 5 o'clock it will be green. In fact, they robbed a bank. They robbed a bank using such car. When they robbed, it was pink. It was identified, and when they went in searching, it was the same number, different color. Okay, so that was we have advantage and disadvantage. Like that, technology has forwarded, and you know that liquid crystals are used in all these pocket cabinet, mobile phone, everything. I think that's what I want to convey the message. Thank you very much.
Enlightening words and amazing experiments.
Carry on.
I now invite our beloved CEO, Mr. Ketan Kumar sir, to share a few thoughts with us.
Last minute, don't worry, we're all heading for lunch. I think it's a wonderful event today, SCIENTIA, a very nicely coined word for inauguration of Science Club. Dear Dr. C.V.Yelamaggad sir, scientist at Center for Nano and Soft Matter Science, the principal, Dr. Channesh, Madam, all the faculty members and students. Did you all enjoy?
Yes, sir.
It's wonderful. So science is very interesting, right?
Yes, sir.
So are you all going to be the next scientist? Say yes, man. If you're a scientist, you can be a great businessman. If you're a scientist, you can work for greatest, center for national importance, or you can be, very, very successful. It's a passport, I feel. So, likewise, thank you, Dr. Yelmaggad sir. You've always been kind. Thank you very much, sir. We appreciate your energy. As always, a very high voltage session you have given, and may God bless you with all the courage. And you have definitely inspired our students, sir. So they will be definitely be scientists. I mean, they won't realize it now when they go out of the portals of the institutions. So when they face the real world, I am sure. And in the days to come, they'll definitely be PhDs or postdoctoral fellows. So they'll definitely, you're a role model to the teachers as well as to the institutes. Thank you very much, sir, for being here. Thank you. And thank you, our principal, Mahablisha sir, and Prupa madam, and all the faculty members who have coordinated the event today. So hope you all enjoyed, and you all want sir to come back?
Yes, sir.
Yes. So sir, we request you to keep coming.
But on a different topic. Have you heard about invisibility?
Yes, sir.
Have you heard about invisibility?
Yes, sir.
No person is there. Person is there physically, but you'll not be able to see. That research we have done, I'll demonstrate. I'll disappear. I'll come next time. Okay? Can I? Am I visible or invisible now? Can I become invisible? Close your eyes.
All of you? Yes, ma'am. So I hope all of you have oriented yourself. There was a lot of orientation, right, from solid state to liquid state, and now you can behave like a crystal. Yeah? So I would like to thank Dr. C.V.Yelamaggad sir for coming over and giving a wonderful talk and educating us on liquid crystals. Thank you so much, sir. Only on the topic, sir spoke on multiple issues as well, right? So I hope all of you will take you'll take it in a positive note, and you also will orient yourself in learning the concepts better. Okay? So I would like to thank sir for giving a wonderful talk. I would like to thank our CEO sir for making this happen. Thank you so much, sir. We have very important guest along with us, Dr. Chennai sir. I would like to thank Chennai sir for his also motivating and guiding us in all our endeavors in moving ahead with science. So thank you, sir. And I would like to thank respected Principal Mahabaleshwar Tunga sir for and the word scientia, when we were just discussing about what topic, sir immediately gave a topic. So I would like to thank sir for supporting for all the events. Thank you so much, sir. And thank you all students for patiently listening, and you had a wonderful time during this learning phase. Thank you so much. And all the faculty members and the group members of this science group, thank you very much. Thank you, sir.
As I mentioned to you, yet again I would like to thank organizer, especially Keith, for giving this wonderful opportunity. I truly enjoyed, sir. Your students are bright, really bright. I think you can do many things. I think you can be scientists. Many of you can be scientists. I see that quality. Congratulations to all of you. All of you. Right. I have come here with a mission that this organization, Soundara Group Association, should step into something else. I mean, it should grow. That's my idea, and I have been inspiring him. This inspiration came when I watched on television. I interviewed Power TV, I think one News First. They on Sunday evening afternoon, I think I was watching something. All of a sudden, this advertisement came. Then I sat through the way our chairman presented Soundara Group Institution. The way chairman presented his story. It started with nothing. Now we have grown into big. It has gone to big organization. Even I cannot imagine. I think we should congratulate him profoundly. Please join me in congratulating him. I don't know how many of you know, I called him soon after the interview. It's not soon after the interview. I called him. Fortunately, I was able to talk to him. Somebody took the phone. Then I said I spent about who cares who is scientist what. But somehow I was able to. I was not knowing that I will be able to talk to him. But I was so blessed that day that I was able to talk to him. Then I presented myself what it is and why I'm talking to him. Very next day, I think 2 days after 2 days, they came. Both of them they came to my institute to see that is the interest. Okay, I said that, sir, your organization should go further. They should open up R&D center. Means it should become a university. You should become a university. Means you should have big round of applause. Now your organization will be slowly, will be alumni, right, in few days. This will be happening sooner or later. We are trying our best that this will open up PhD centers. Now after PG, now you are there trying PG. I'll be there always with him. Okay, as a worker, nothing else. I mean, like I'm like a chairman only. As a worker, I'm inspiring them. I'm inspiring them a lot. To first they start with PG and then come to PhD, and you will have a big organization, research organization in the Soundara Group Institution will add this dimension, new dimension, and therefore this will be university, deemed to be university. Soundara Group Institution, the way sir sir said about his life and how he is growing and the kind of efforts they are putting. I wish you wish them the best and wish them good luck and wish you all the best. Thank you very much.
पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मागे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय